All right, let's talk about some ways that recursion can be used to manipulate numbers. So in this function, you'll notice we're not returning anything, so it's a print recursion type situation again. And if the input is 6245, let's see what it does. It says if the input's not 0, we're supposed to print out the result of taking our input and finding the remainder when dividing it by 10. And so 6245 remainder when divided by 10 is the number 5. So we're going to have the printing of the number 5, followed by a call to the operation command, once again with the number that we're given, 6245 divided by 10. So that's 624, right? So we're doing integer division, it just truncates off the ones place. So what does op624 do? Well, because our input is not 0, it's going to print out the result of finding the remainder divided by 10, which at this point you should see is just going to be the ones place, followed by calling the function again op on the result of dividing the number by 10, which is sort of like chopping off the ones place, so op62. So what does op62 do? Well, it prints out the ones place, which is 2, followed by call the function again op on what's left if you chop off the ones place, so 6. And then when you call op again on 6, it's going to print out the result of doing 6 mod 10. I know that's tricky for a lot of people. That's just the number 6. The remainder when you divide 6 by 10 is just 6. Then it calls the function again on 0, right? 6 divided by 10 is 0. But when you call that function, it doesn't do anything because 0 is not equal to 0 is false. So then it doesn't do anything in that case. So the values that are printed out are 5, 4, 2, and 6. It's a terrible 5. 5, 4, 2, 6. And you'll notice that it's the original number, but just in reverse. So this is a way to reverse a number. Now, that's not particularly useful if you want to reverse the number and use it mathematically. Like you want to reverse it and then do a calculation with the reversal. So this is another version of it that's not print recursion. This one's actually going to do an evaluation that gives us a number that we can use in our program. And you can see that because our function has an integer return type. So we'll go through the exact same process, but what it says is if n is 0, we return 0. Otherwise, we're going to return the result of taking our number mod 10, so just the ones place. In that case, that's the number 5. And what we want to add to that is the operation of the exact same function call, but on the number 6245 divided by 10, which is 624. Okay, so what does op624 do? It's not the base case, so this, once again, I think this is a good idea right here. This gives you the ones place, and this gives you the rest. All right, so it's supposed to be the ones place of 624, so that's 4, plus the operation on the rest of the number, which is 62. So what does op62 do? Well, it's the ones place plus the operation on the rest of the number. And what's the operation on 6? It's the ones place plus the operation on, this one's where it's a little weird, 6 divided by 10 is 0. And then op of 0, you can see when the input's 0, it just gives us 0. And so in this case, we're going to add up all the digits, 5 plus 4 plus 2 plus 6, and that gives us 17. So whereas the first example is a reversal, this one is what's called a digital sum. It adds up all the digits. It wouldn't be too hard to modify our program to make it actually do a reversal. I'm trying to remember off the top of my head where we need to multiply something. I believe we have to multiply by 10 somewhere, and I'm not going to do this off the top of my head. But this is what it would look like if you had code that was doing a digital sum, and this is code that's currently doing a reversal.